Another Nobel laureate and the father of modern science, Albert Einstein, showed that all forms of radiation travel in wave packets which acted like particles in some ways. He called these packets as photons. The energy of photons increases as the wavelength decreases. The wavelength is related to frequency, that is to say the number of vibrations or waves or cycles per second. The shorter the wavelength, the higher is the frequency and greater the energy. Thus, gamma rays with the shorter wavelength are the most energetic. And now we would like to discuss about the very theory that relating to temperature, and in that connection every object which is at a temperature above absolute zero, and that is minus 273.16 degree centigrade, radiates photons of all kinds. The average energy of the photons emitted increases with the temperature. We experience this heat during the peak period, that is the known invisible light radiation. But even objects which are not hot enough to glow like the sun still radiate quantities of infrared radiation. For instance, our own bodies. Even objects below our body temperature, cool bodies, radiate microwaves and longer radio waves. These radiations called thermal radiations can indicate the temperature levels of the objects emitting them. So, another important part of the universe and that we would like to discuss is about the galaxies. So, galaxies are mainly of three different kinds of galaxies that we found. One is spiral galaxy, then the second was the elliptical galaxy, and the third one is regarding the irregular galaxies, then the Milky Way, the Magellanic Cloud, then the Andromeda galaxy. So, in that connection, we would like to discuss that a structural analysis of the known galaxies bring out three major forms, then these three different forms as the spiral, the elliptical, and the irregular. While the spiral galaxies have a central nucleus with great spiral arms trailing round it, the Milky Way and the Andromeda galaxy belong to this group. A special type of spiral galaxies what are called the barred spirals, which have a central bar as a nucleus. The spiral Galaxies comprise some 80% of the galaxies so far known, while elliptical galaxies slow, purely elliptical, shape without any spiral arms. They range in shape from spherical ellipticals to extremely saucer-shaped ones, and account for about 17% of the known galaxies. While irregulars, as the name suggests, show no definite geometric patterns or shape. So our own galaxy, the Milky Way, belongs to a cluster of some 24 galaxies called the local group. This group covers an area about 3 million light years in diameter. The two nearest galaxies are the large Magellanic Cloud and the small Magellanic Cloud, so called after the world navigator Magellan, who first spotted them. The large cloud is about 155,000 light years from us, with a maximum diameter of some 40,000 light years, and contains some 5 to 10 billion stars. The small Magellan Cloud has only a population of 1 to 2 billion stars. The two largest galaxies in the group are the Milky Way and the Andromeda Galaxy, both of them spiral. While Andromeda Galaxy is of special interest to us because it appears that our galaxy and M31 are actually approaching each other at a rather more speed of some 50 kilometers per second. The local group is a term loosely applied to indicate our galaxy and its nearby galaxies. The group numbers around 2 dozen. Some, like the Milky, are even suspected to be in the group. The latest known members of the group is a dwarf galaxy discovered by an Australian observer. So, in that context, we'll discuss another important part of the universe, that is the Milky Way. The Milky Way is our home galaxy. A peculiar feature of this galaxy is a bright band of light that runs almost in a perfect circle through it. Milky Way belongs to a cluster of some 24 galaxies called the local group. The Milky Way had so fascinated our ancestors among all nations that they had given it pretty names and had woven fanciful legends about it. The Actus of Central Asia called it the footprints of God, and the Eskimos called it the path of white ashes. The ancient Greeks called it the road to the palace of the heavens. The Chinese called it as the celestial river, and the Hebrews called it as the river of light. The ancient Indians called it the Akash Ganga or the celestial Ganges. The Milky Way is a spiral galaxy. The main body of the galaxy is a disk 1 lakh light years across with a globular nucleus of about 16,000 light years in diameter and far-stretching spiral arms, in one of which our solar system is located. The galaxy consists of over 100 billion stars rotating about the center in a stately average period of some 250 million years. The principal gravitational force that controls this rotation is produced by the star clouds at the center, which have a total mass about 50 billion stars. The mass of the entire Milky Way is calculated to be a little more than 100 billion times the mass of the Sun. The stellar population of the Milky Way is made of 3 categories of stars. First categories, there are the stars in the half and spirals of the Milky Way. The Sun belongs to this group of stars. These groups are called open or galactic clusters. Beyond the disk and the open clusters lie the halo stars. Many of these stars from miniature galaxies consisting and containing tens of thousands of stars. These are called globular clusters. They contain very old stars. Beyond the globular clusters, there are several million individual stars that run around on the outskirts of the Milky Way. All these form part of the galaxy. So, now we'll go to another important part of the universe, and that is regarding the stars. So, in connection to stars, we found the lone stars, the double stars, multiple stars, red giants, then variable stars, the Novae and Supernovae events. So, stars account for 98% of matter in a galaxy. The rest 2% consist of interstellar or galactic gas and dust in a very attenuated form. So, stars tend to form groups such as the lone stars going to their own are the exception rather than the rule in the universe. Single stars do not number more than 25% of the stellar population. Double stars account for some 33%. The rest are multiple stars. And there is in this Scorpio is actually two stars. One is Capella and Alpha Centauri. Comprise three stars each, while Castor consists of six stars. Stars which appear single to the naked eye are sometimes found to be double stars or binaries in the telescope. These are two stars revolving around a common center of gravity. They are found in orbital motion round each other in periods varying from about 1 year to many thousand years. When the hydrogen in a star is depleted, its outer regions swell and redden. This is the first sign of age. All stars are called the red giants. Our star, the sun, is expected to turn into a red star of this type in another 5 billion years. Red giants are appropriately named. They have gigantic dimensions. And regarding the variable stars or stars that show varying degrees of luminosity. And now we'll discuss about that events. The Novae and Supernova are stars whose brightness increases suddenly by 10 to 20 magnitudes or more, and then fades gradually into normal brightness. The distinction between the two types has not been precisely explained. It would appear that they differ in degree and not in kind. The sudden increase in brightness is attributed to a partial or outright explosion. So in nova it seems that only the outer shell explodes, whereas in supernova the entire star explodes. Nova occur more frequently than supernova. Supernova are stars whose brightness increases to 20 magnitudes or more. As Professor C.F. Powell puts it, the whole structure of star is blown to pieces. It flares off in brilliance so that it extinguishes luminously for the first 30 days following the explosion is equal to about 1,000 million of our suns. So in that connection, as we already discussed, the next important most part of the universe is the solar system, and it consists the planets, and such planets are either inner planets and outer planets. Besides that, the satellites, asteroids, comets. So now we'll discuss the most important part of the universe, that is the solar system, and it is centered in the sun. The sun is the head of a family of 9 planets such as Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto. Not less than 46 satellites accompanying the planets, hundreds of asteroids and thousands of comets. The solar system is tucked away in a corner of the Milky Way at a distance about 30,000 to 33,000 light years from the center of the galaxy. The solar system originated in a primitive solar nebula, a rotating disk of gas and dust. It is from this rotating disk that the planets and the rest of the solar system evolved. The term planets show in the very inner circle. And as we found from the ancient astronomical history, the first known planets were named after the Roman gods such as Mercury, Venus, Mars, Jupiter, and Saturn. And the outer planets, when they were discovered later, were also named according to the old pattern, like Uranus, Neptune, and Plato. So the planets are divided into the inner planets and the outer planets. The inner planets are Mercury, Venus, Earth, and Mars. The Earth is the largest of the inner planets and the densest of all planets. All the inner planets are dense, rocky bodies and are collectively called terrestrial planets because they resemble the Earth. The outer planets, Jupiter, Saturn, Uranus, and Neptune, are very big with large satellite families. They are composed mostly of such elements as hydrogen and helium. These planets are called Trojan as the outermost planet, that is the Pluto, is in a class by itself. It is supposed to be a dense planet like the inner planets, although it is the farthest of the outer planets. And now we'll discuss the next most important part of the universe, and that is the sun, and relating to that we'll discuss what is cosmic air and the very composition of sun. Then what is